Hi guys, you are welcome to Craze Control Automation. Yeah, today we are going to look at thermal overload relay. Okay, thermal overload relay. All right, how it operates, all the buttons on it. Okay, we are going to explain it, and then also the bars here. All right. So if you are new to this channel, I will urge you that you subscribe to this channel. Okay, and then you hit on the bell icon. You select all to receive all my videos. All right. So let's get started. So engineers, this is the overload that we are coming to look at. Okay, yeah. So when you talk of overload, what does it mean? An overload is a protective device that protects an induction motor under overload condition, under abnormal condition. All right. So now let's see these buttons and then the terminals here. All right, these buttons and then the terminals. Okay, so over here we have this terminal. All right, terminal T1, T2, and then T3 or 2, 4, 6. All right, this is where we connect to the motor. All right, we connect cables here to the motor. All right, yeah, this is the output of the overload, and then this is the input. Okay, so these bars, they are the heaters. We call them heaters. All right, yeah, heaters. So we always connect this one, these heaters in series with the line. All right, in series with the line. So now when you look at this diagram, see this diagram here. Okay, these symbols, these are the heater symbols. Okay, heater symbols. All right, so it is called thermal overload relay. Okay, so it is always, they are connected in series, okay, with the main line. Okay, so this is the contactor. Okay, this is the contactor. All right, and then we have our motor here, 3-phase motor. Okay, yeah, these are 3-phase motor. All right, okay, so always these heaters are connected in series with the main line. All right, with the main line. So this is it. All right, yeah. So here we have these contacts. These are the normally open contacts and then normally closed contact. All right, normally open contact, normally closed contact. So let's look at this terminals here. Okay, this one that you are seeing here, 97, 98, they are the normally open contact. They are these terminals. They are these terminals. Okay, 97, 98. We have 95. Okay, and then 96. These are the close contacts. Close contacts. These are the open contacts. Okay, normally open contacts, normally close contacts. So now, under normal conditions, under conditions where the overload is not tripped, these contacts, the 97, 98, they are normally open. Okay, and then 95, 96. Okay, 95, 96, they are the close contacts. They are always close. But the moment the overload trips, the moment this overload trips, okay, these contacts, they change their state. This 97, 98, they become normally close. They close. Okay, and then the 95, 96, they become normally open. All right, they open. Okay, so these are the contacts, the symbols. All right, so when the overload, okay, is stripped, this 97, 98, they will close, and then this 95, 96, they will open. All right, that is when the overload is stripped. Okay, all right, so let's see this buttons here. Okay, we have this button. All right, you see this way. Okay, it's like it is out, right? It's a push, it's a spring loaded button. You press it this way. All right, yeah. So this is the reset button. That is the reset button. Okay, yeah, that is the reset button. So what is the function of this? When the overload trips, okay, when it trips, this is where you use to reset the overload. Okay, so you can see some ratings here, some letters. We have H and A. H and A. The H means hand. Then the A means auto. Okay, so when you put this button, okay, on H, it means that when the overload trips, okay, and then after the fault has been cleared or has been resolved, okay, you have to come to the overload and press on this button to reset the overload. Okay, So let's say it is running an induction motor and there was an overload, and then the overload tripped, all right, and then the motor stopped, all right. So when the overload tripped, this 95, 96, 95, 96, they open their contacts, okay, to trip, to de-energize their contactor, all right, this contactor, okay. You look at that, all right. So now, in that case, okay, after we resolve the problem, okay, someone has to come and press on this button to reset it by hand, okay. And then when you put it on auto, all right, on auto, it means that when a fault occurs under overload condition, okay, and after the fault has been resolved, no one will come to the overload. The moment the fault is resolved, the overload would reset itself, okay, because it is put on auto. Auto means after the fault has been resolved, the overload will reset itself. No one should come there. So that is the function of this, okay. So let's see how we put this button in either hand or auto. So now it is on hand mode, all right. It is on hand mode. See the H. When this button is on top, okay, it's at the top position. At the top position, it means that it is on hand mode, okay. So now let's put it on auto and see. You do that by pressing it, okay. You press it, okay. You press it, or let's push this one first. Let's open the gate, this one first, all right. And then you push it inside like this, okay. You see that? You push it this way, okay. Yeah. And then after pushing it, okay, you turn it. You turn it this way, all right. You turn this way, okay. Let me come back to hand again. So after pressing it, then we turn it, okay. Yeah, to auto, all right. So now it is in auto mode. So you see that now it has logged inside. It has logged inside, right? It has logged inside. So in this case, when the overload trips, okay, and the fault has been resolved, it will reset itself, okay. Yeah, okay. Let me put it back in hand mode, okay. Okay, let's look at this red button here. This button is the stop button, okay, all right. It works the same way as our normally stop push button, okay. So when the overload is attached to your contactor, all right, and then it is running an induction motor. When this button is being pressed, all right, the motor will stop. Why would it stop? Because when this button is pressed, when the red button is pressed, okay, this contact, the 95, 96, they will open. They will open. This contact will open, but this one is not part. The 97, 98 is not part, but it is this one, okay. So when you press on this button whilst the motor is operating, is working, the moment you press it, this, okay, this contact, okay, would open to de-energize the contactor, all right, to de-energize the contactor, okay. So the moment we release our hand like this, it will come back and then it will close back again, okay, and then the contactor would energize again, okay. But when we are using this button, all right, this button, it means that we are not including start and stop push button, all right. Yes. So the moment we switch on the main supply, okay, the moment we switch on the main supply, the contactor will energize, okay. But when you want to stop the motor momentarily, let's say in short time, you can press the overload this side, okay, to de-energize the contactor, all right. Okay. So now let's come to this knob, all right. This knob, okay. See this knob? This is the current setting knob. The current setting knob, okay. So let's say if the motor is rated 10 amps or 5 amps, this is where you set, okay, the current, all right. So you see here there are some ratings here, okay, there are some numbers there, all right. Yeah, we have auto, we have 7, 8, 9, and then 10, okay. And also, if you want to understand how to size an overload, all right, then kindly watch this video, okay. Yeah, if you want to understand how to size an overload, watch this video. So let's continue. And now let's look at this side. Let's look at this side, okay. We have test, and then there's a small red button inside here, right. There's a red small button here. So that button is where we trip the overload. We test the overload to see that under abnormal condition or under overload condition, when it trips, okay, will this contact open or not? Will this contact change their state or not? Okay, so in case you want to trip the overload, all right, you press this button. Okay, so the moment you press it, okay, this contact will change their state. The 97, 98 will become normally closed. Okay, and then the 95, 96, which is a normally closed, it will become normally open. All right, and when you want to reset it, you have to press this reset button. All right, okay, so now let's test this contact. See here, so now we are testing the this contact, this auxiliary contact, okay, 95, 96 and C. So now under normal condition, under condition where the overload is not tripped, okay, this contact is normally closed. So let's test and see. You see that there is a beep from our meter. All right, our meter is beeping. Okay, yeah, it's beeping. Let's test the 97, 98. You see, it is normally open. All right, normal open, so there's no beep or there's no sound, right? But the 95, 96 is closed. Okay, it's normally closed, right? Okay, so now what you are coming to do is, all right, I'm going to press on this button. Okay, so this way on the red button. All right, I'm pressing on the red button. Okay, as I press it, you see it has stopped. As I raise my hand, you see it is closed again. When I press it, it stopped. It closed. It stops. So that is the function of this button. All right. Okay. So we are going to press on the trip button. All right, or the test button. This button inside. Okay. So I'm going to press it. All right. So when I press it, the overload will trip. Okay. So let me press it and see. I have pressed it. All right. So let's test the contact and see the 95, 96. All right, you see that it is not beeping, right? It has tripped. Okay, it is not beeping. Okay, let's see here, 97, 98. Okay, yeah, so that is it. Okay, so now we are coming to reset the overload. Okay, so don't forget that we trip the overload under hand condition. Okay, this button, the reset button, is on hand mode. All right, so in this case we have to press it before we can reset the overload. All right, so let's press it. I've pressed it. All right, let's test back again. You see the 95, 96, it is closed again. All right, let's test this one. It is open back. All right, it is open back. Okay, so now we trip the overload under hand condition. Okay, so we are come to trip it again. Okay, under auto condition. All right, so let's push this button. Okay, on auto. All right, so let's push it and turn it. Okay, yes, so now it is on auto, and then let's press on the trip again. All right, let's press this again. Okay, let's press it again. We have pressed it, right? All right, so now let's test and see. Let's test the 95, 96. You see it is closed. It is closed. All right, it is closed. You see that it is closed. It is open. So what I'm going to do is, okay, I'm going to put the probes or the leads on it like this. So I'm going to press on the trip. Okay, I'm going to press this using the screwdriver. Let's see. You see it has gone off, right? It has gone off. Let me take it off. You see it is beeping again, right? Let me show it clear. Then press it again. You see it has gone off. All right, let me take it out. You see that, because the moment you take it out, because this button is on auto mode, okay, it will reset itself automatically. All right, so this is basically the function of these buttons. All right, yeah. Now let me come back to this bars, the heaters. Okay, let me come back to the heaters. Okay, so now these heaters, all right, let me put the reset back in hand mode. All right, back in hand mode. Okay, so now these heaters, okay, these heaters, they are normally closed. The heaters, okay, they are normally closed. So let's see. You see that? You see it? Okay, this way. You see it? You see it? Okay, and then this one. You see it, right? So now let's see that if under overload condition, when the overload trips, okay, does this contact open or what? Okay, when the overload trips, does it open? No, because they are normally closed. Okay, when the overload trips, okay, it is this contact, the 9596, that opens. Okay, they change their state. This contact, they are fixed contact. They are not movable, right? These are the movable. These are fixed. Okay, so now let's attach the overload to the contactor like this way. Okay, yeah, this way. All right, so now we have attached the overload to the contactor. Okay, yeah, so we have attached it to the contactor output. All right, 1 2 3, 1 2 3. Okay, yeah, so let's see what happens. We are come to trip the overload. All right, we are come to trip the overload. Let's see. Okay, but before that, let's test this contact. All right, these terminals. Okay, here and the output of the overload, and see. You see that it is beeping, right? Let's see here too. It is beeping. Okay, let's see here. It is beeping, right? You see that? Yeah, so that is how it operates. Okay, so let's trip the overload. All right, so let's open this gate. Yeah, so we are tripping it. Okay, under hand condition. Okay, so I have tripped it. All right, I have tripped it. Okay, so let's test the 9596. You see that it is not sounding. It is not giving sound because it has opened. Let's see 97, 98. You see that it is beeping, right? So because it has tripped. But let's check these heaters. Okay, this main bus. All right, so let's test here and see. You see they are still beeping. They are still closed. Let's see here. They are still closed. Let's see here. They are still closed. So it means that under the overload condition, okay, these main bars, the heaters, they don't open. They are always fixed. Okay, but it is this contact, this auxiliary contact, the 95, 96, and the 97, 98, they change their state. All right, they change their state, but this main contact doesn't change their state. They are fixed contact. Okay, they are fixed contact. All right, so always we connect the 95, 96 to the contactor coil. Okay, to the contactor coil. So let's say you connect, okay, this way to the contactor coil, this way. Okay, this way. All right, so you have K1. Okay, so this is the K1. All right, this is the K1. This is the coil. So this, and then here will be our live. Okay, line 1. All right, line 1, or it will pass through a push button. Okay, yeah, but for the purpose of demonstration, I am not showing a push button. Okay, yeah, so now when the overload trips, okay, when the overload trips, the 95, 96, it will open. Okay, so it means that it will open. Okay, to open this, when the overload trips, this contact will open. Okay, and it will de-energize the contactor. It will de-energize the contactor. So when the contactor de-energizes, this contact, okay, this contact, they will open. They will go back to their open state this way, right? Okay, the moment this contactor energizes, this coil energizes. This is the coil. Okay, so A1, A2. The moment it energizes, this contact, all right, they close. All right, they will close. Okay, but when the overload trips, all right, when the overload trips, okay, this contact, okay, they will open. 95 and 6, it will open. When it opens, it will de-energize the coil, and therefore this contact will return back to their normally open state. Okay, so in that case, there is no current. The current is going to stop flowing. Okay, it is going to stop flowing, and then the motor, okay, the motor would be off. The motor will turn off. But this contact, they don't open, they are always closed, okay, as we tested. All right, now let's see how the overload, okay, trips. How does it sense large current? Okay, now I mentioned something that these heaters, all right, the heaters, okay, the heaters, let me take it off. Yeah, you see the heaters, all right, they are bimetallic, okay, elements, okay, heaters, all right. So always they are in series. You see here the diagram, okay, they are in series with the main line, okay. So now when, let's say, the current flowing through this line, okay, this line, it's let's say 10 amps, okay, 10 amps, all right, 10 amps, okay, the current are 10 amps, okay, so they are flowing through this. So now when the motor is overloaded, all right, when the motor is overloaded, okay, in that case the motor is going to draw more current, okay, it's going to draw more current. So in that case, let's say the current is going to be, let's say 13 amps, okay, 13 amps, all right, 13 amps, okay, 13 amps. So in this case, the overload is going to sense this 13 amps. So when the 13 amps, okay, flows through these heaters, the heater, okay, it will heat, they will become very much heated, okay, they will heat up, So when they heat up, okay, there are some bimetallic strip elements, okay, just beside them, all right, beside them, they will burn, okay, they will burn. When they burn, they are attached to this contact, those bimetallic that bimetallic strip, okay, they work the same way like a thermostat, okay. So when this 13 amp flows through these heaters, they are heaters, okay, normal heater, all right. But when this current, the 10 amps flows through under normal conditions, since we have set the overload to 10 amps or 11 amps, okay, or 11 amps, when this current is flowing through, there is no way they are going to heat up. They are not going to get heated. But the moment they're under overload condition, the moment the motor is overloaded, okay, this current, the current is going to increase. So let's say 13 amps. So when this 13 amps flows through this heaters, okay, they are going to heat up. So when they heat up, the bimetallic strip, okay, beside them, this like they are beside them this way, right? This way, okay. They are beside them this way, right? Something like this, okay, something like this, okay, yeah, something like that, okay, this way, all right, this way, okay. So when they heat up, okay, this bimetallic, okay, they will burn, okay, and then they are also attached, okay, they are attached to this contact, okay, to this contact this way, okay, they are attached to this contact this way, all right, yeah, they are attached to this contact. So when this element, okay, they heat, okay, this metal, this bimetallic strip metals, they will burn, and then they will push, okay, they will push this contact. So in that case, this 95, 96, it is going to open, and then 97, 98, it is going to close, all right, yeah. So this is basically how an overload, okay, operates. This is basically how an overload operates, all right. So mostly we use an indicator lamp here, okay, indicator lamp, okay. So here could also be line 1, okay, line 1, all right, line 1, okay, and then here will be our neutral line, okay. So when it trips, this 97, 98, it will close, okay, and then current will flow through this bulb. Then the bulb will light up to indicate that the motor has tripped, the overload has tripped, all right. In that case, this contact is going to open, this contact is going to close. So engineers, basically this is how an overload operates, okay, this is how an overload operates, all right. So let's stay tuned. If you are new to this channel, I'll urge you that you subscribe to this channel, okay, and also you like the video, you put down your comment, and you share the video to your friends, okay. We are going to have more practical and educational videos, okay, which are more precise and concise. So I'll see you in my next tutorials. Thank you.